Hey, hello friends. There was some issue. I just restarted. Okay, let me go ahead with a poll question. Are you able to see my screen and hear me? Yes or no? Please, can you respond to this poll question? Um, yeah. No, able to see my screen and 50%. That's a little alarming. So this is a screen, guys. So if you are able to see my screen and hear me, please let me know. I'll be more than happy to, proceed further with the session. So now I'll check this. Yep, 80%. Once again, I'll just write the statement here so that people who have issues will fix it. 80% of participants are able to see my screen and also hear me. Okay. If you have any issues, then please check your audio settings and internet. And if need be, check your browser settings. So 80% of participants are able to see my screen and able to hear me. If you have any issues, then please check your audio settings and internet and also check your browser settings. All right, so that's the point from my side. Now, let me see. Yep, wonderful. So let's move on, friends. Yesterday, during the discussion, we discussed about applications of supply chain, and we understood the entire value chain of the supply chain management, and then we understood what are the various areas where you can implement analytics. Here is yet another interesting use case. Within your inventory, say there is a person by name Jesse who enters, instead of retail store, I'll replace it with who enters inventory. Who enters inventory store. And she, over a period of time, adds the list of components that she has to pick from the inventory on the mobile app. In mobile app, in wish list, she keeps adding list of all the components which she wants to pick from an inventory store. The moment she enters the inventory store using the inventory app on a mobile, there is something called as iBeacon. It's like a router, like your Wi-Fi router. It will detect that Jesse is in the store. Through what? Through this mobile application. Mobile application synchronizes wirelessly with this iBeacon, which is like a Wi-Fi router, and it quickly determines what are the list of items which are there in the wish list. And very interesting enough, it is going to route Jesse to those locations where these components exist in inventory. So this is wish list of the various components which are needed by Jessie for proceeding further with the manufacturing process. So the moment she enters the store, automatically her mobile app synchronizes, and within the store there is something called as geofencing. Using geofencing, it will route saying that, okay, she wants to pick 5 components. One component is here, another component is here, third component is here, right? Fourth component here. In that way, say different components are there. Not just helping Jessie locate where the components are, but this technology, location sensor data, would guide and help Jessie find the shortest path. Not that if Jessie is here, it will not say she entered and say somewhere here you have exit. So it's going to take Jessie to this, and then exit. Not in a haphazard manner. It's going to direct Jessie to pick up all those components and then exit. Such a cool feature, right? And then Jessie, the moment she picks up the components, to double confirm whether those components are right components or not, Jessie puts all these components in a smart cart. Okay, and she goes to the aisle, and you'll have a tablet here on the cart which shows the relevant information about the components or products on the aisle itself. The moment Jessie takes this cart along with her to this location, it will tell what are the various components that are available here and how those components can be used, maybe a brief description about that component, which will double confirm that that's the exact component or product that Jessie needs. Yet another cool feature. And then Jessie picks up her products from the smart shelf. All these aisles have smart shelves. The moment she picks up a component, it will automatically update the backend application, and it updates the shelf replenishment management system. Real time, it is updated. Meaning how many components are replenished, are taken. And there'll be some threshold saying that, each component, minimum 10% of each component should be there in inventory before refilling it. From that perspective, it will be very helpful. And then Jessie, say, is in some section and picks up tool, say hammer. Tablet on card displays a few applications that uses the hammer. Then Jessie liked the applications of the hammer, and then the app shows all the activities needed to accomplish a task. Okay, and it will show the supporting tools. The supporting tools that Jessie can pick up, so that just using hammer she might not be able to accomplish all the tasks. Maybe hammer and a nail. Could be, yeah. Then Jessie comes across smart display like this. It has distance sensors and face recognition to identify that it's a female, to identify that it's Jessie over there, and it shows a few other components which might be of interest to her. If she's interested, she can get some coupons But for internal inventory, that doesn't make sense. But this is also a functionality which is possible. If you think from retail perspective, supply chain is everywhere. Supply chain can be in retail also, right? I'm just trying to correlate this use case with manufacturing, because manufacturing and supply chain are very closely coupled. Okay, and then the senses of the cart. The moment you keep placing products in the cart, it will automatically calculate the total cost. And it will show the bill to Jesse. Jesse can say, hey, bill to my department. And Jesse might say, hey, let me pay it now, but I'll pay it using smart payment. That's it. So the entire journey of a person from start until end is kind of digitally transformed, and that's called as digital transformation. Okay, so these are the kind of applications which exist. Awesome applications, isn't it? Yeah, and then we thought of discussing something else, and that something else is this part: descriptive, predictive, and prescriptive analytics. And even before that, let me quickly see. There are any questions here? What questions? Will we be getting this recorded video? No, Thomas. You will not be getting the recorded video as such. Okay. But post this from, I think, this Saturday onwards, you'll have continuation of this. And people who want to enroll by making payment, you can. I'm going to speak about that towards the end. Okay, our team is going to post certain details on the chat, and then you can get in touch with the team and they will guide you with the registration process. Okay, so you have descriptive analytics, in which you have supply chain mapping and supply chain visualization. Please do not forget these four things: source, make, deliver, return. These are the four activities which are predominantly performed in any supply chain management. One is descriptive. Descriptive analytics applications is all about making use of data which comes from maybe GPS, global positioning systems, maybe from RFIDs, radio frequency identification chips, and from a few other data visualization tools. Now, once you get this data of the various components and various products, you can provide managers with real-time information regarding what is the location of different goods, right? In the supply chain, in the entire supply chain, where are the goods? For example, say you're shipping vaccines. Now, this is one big problem, and because of COVID, supply chain management or supply chain analytics has become even more relevant for a lot of pharmaceutical companies and a lot of shipment or logistics related companies. Because vaccines have to be maintained at minus 40 degrees Celsius, etc. What if the temperature drops? Vaccines might become useless. Vaccines might get spoiled. They might become ineffective. How do we counter that? So you need sensors which will throughout monitor and keep sending you real-time data. Right? Say a few vaccines are getting shipped from the UK to Malaysia. Just as an example, say AstraZeneca is getting shipped from UK to Malaysia. Throughout the journey, vaccine has to be maintained at minus 40 degrees Celsius. Is it being maintained? How do you know? Through sensors. Okay, through sensors, real-time data is obtained, and then you keep tracking it. How many vaccines are sent? If you can track that information, usually using micro sensors, people track that so that they can, keep a track of how many vaccines are given, how many vaccines are in which location, in which state. Is vaccines effective usage being done, so on and so forth. Or maybe for the carton, if not for each vaccine, at least for the carton. One carton of vaccine box, he has 10,000 vaccines, just as an example. So at least at a carton level where the various vaccines are shared. And also, it provides information on quantities of goods in supply chain. Is it still in production, or are people still sourcing the raw material to produce vaccines? Or are they producing? Have they produced? Was it delivered? Or was some vials of vaccine returned? Yeah, everything can be tracked end to end. And all these would happen real time. If you have industrial IoT sensors and data analytics. Try to understand the importance of industrial IoT sensors, friends. It's creating revolution. The kind of analytics that you can do, it simply explodes. You'll have a different perspective altogether. The moment you know that, okay, here I believe I can use a sensor, get the data and do analytics. Could be descriptive, predictive, or prescriptive analytics. Next thing is predictive analytics. You can do demand forecasting. As I've told you, that is one of the most important things. Demand forecasting. Depending on the demand forecasting done, you can decide on, how much amount of raw material you need to source. How many do you want to make? How many to deliver? What percentage would be returned? How do you handle that? Everything boils down to the demand and supply. Okay, if you go wrong with forecasting, things might get really, really crazy. Let me show you one example. Yeah, in India also it is implemented, my dear friend Rehan. If you're asking me a question on was it implemented, yes, it's implemented. Okay, so here, DEX, I believe. Digital Electronics Corporation. Digital Equipment Corporation was once threatening to, purchase IBM, acquire. They were planning to acquire, IBM. But then they backed off, not sure why, but, they were producing voice over internet protocol machines, telephones, VoIP devices. And they were extremely successful. They were just left, right, and center acquiring various companies, and they were at their prime. You would say that if there is any company in digital equipment production, manufacturing, it should be like DEC. That's what people used to say. And on one fine day, they forecasted the demand for VoIP devices, and that was an over forecasting that they've done. When you go wrong with forecasting, it might be over forecasting or under forecasting. If you under forecast, you produce less. But here they're over forecasted. When you over forecast, you produce more. And the life of any digital, product, life of a digital product is limited. If your people do not purchase that within 1 year or so, I mean, you cannot sell those. You just need to sell it at a massive discount, or that's it. You need to shred it. If you sell it at a massive discount, people might assume that your next set of products also will come out at a massive discount. If you shred them, you lose the entire money that you have put in acquiring the raw material, producing human resources, machinery wear and tear, right? Nothing, no money you are going to get back. You can read this. And then it has become defunct. Defunct means doesn't exist. Such a big company, they have overproduced and then gone. Just like that. So forecasting is very important. If you under forecast, then you lose market share. But if you over forecast, that might be even dangerous. Okay, either ways, it's very important. I mean, under forecasting also is dangerous, my dear friends. For example, which guy? Italian scientists jailed for under forecasting earthquake. Okay, so Italian scientists were sentenced to 6 years for earthquake. Why? Because they have under forecasted the earthquake on a richer scale. Earthquake is measured on a richer scale, intensity of earthquake. The moment they under forecasted, people were pretty relaxed that, okay, it's not going to be very devastating. But earthquake was of higher, richer scale. From one richer scale to another, it's a supposedly 1,000 times more intense. From forecasting, you might say richer scale 5. If on the richer scale, if it becomes 10, okay, or instead of 5, if it becomes 6, that's it. Yeah, I mean, it'll be causing loss of property, loss of lives, and you, worst case, might end up in jail. Be rest assured that if you do anything mischievous, if you're implementing inappropriate techniques, and if things go wrong, that would be end of your career. You might come up in media, on social media or on news channels, and who will hire you after that? Okay. So demand forecasting happens at various levels. At strategic level, as we discussed yesterday, at tactical level, at operational level, at various levels. Then all of these demand forecasting helps you do what? Fine, you're doing demand forecasting, but what will it help you do? It will help you perform network design. Okay, I'll tell you what are the various topics that we'll learn. And network design is one key thing. You can do capacity planning, how many people are needed, how many machines are needed, so on and so forth. Then you can do production planning. Then you can do inventory management. Then you have prescriptive analytics. Here, focus will be on mathematical optimization, simulation techniques, right? Which will help you take advanced decisions. Automatically, decisions will be taken. Okay, we'll touch upon a few of these things. We'll certainly not have time to delve very deep into these, but yeah, we would touch upon a few. Okay. So these are a few things that you can expect, friends. Okay, and what else? Now, what else for that? I'm going to take you to this, but before I move there, let me first cover all the concepts that we are going to talk about as part of supply chain analytics. Here it is. Okay. So, it's not for 40 hours. I want to remind you, no assignments, no projects. It's purely training. Okay, because this is a specialized module. We need to do some updates on our website, which we'll do. Training will be for 12 hours. Okay, I'll be making you do some hands-on, and yeah, is this good enough? Kind of, but we are not going to train you on very advanced topics. No, that's not the intention at all. What will we understand? You'll understand supply chain 101, means the basics of supply chain. How does it work? What are the various departments which get included in finer detail? Since we have already discussed about a few of the applications of data science and AI, will not touch upon that. For any analytics projects that you work upon, or I would say for majority of the analytics projects, you need the background of operations research. So we will briefly touch upon optimization and simulation. I'll do a few use cases and show you. And then we will get into supply chain analytics. Our focus will be on supply chain operations reference model. Then we will switch to supply chain measures of performance. And these are the various measures of performance that exist. Right? So return on equity, return on assets, right? How do you calculate accounts payable turnover? Then how do you calculate accounts receivable turnover? Right? How do you calculate inventory? How do you calculate PPT? Property, plant, equipment turnover. I mean, people from accounting would maybe appreciate this a lot more. What are the design drivers? What are the various things that you need to consider while designing your supply chain? That's going to be very important. What is the role of for example, here you will understand on what is the role of facility going to be. What is the facility role going to be? Then facility location. Then capacity allocation. Capacity allocation. Then you'll have market and supply allocation. Right? What are the various competitive factors? What is the framework of network design decisions? Distribution networks. Right? I mean, how does the cost escalate? What do you mean by regional facility configuration? Regional facility configuration. What should that configuration be? How many do you need to have? Network optimization models. We will discuss about something called as capacitated plant location model. Some amount of math would certainly be there. right? How do I come up with constraints, etc., right? And application of taxes. If you were to consider taxation also, then would your supply chain change? Sure, it would. How would it change? We'll understand. You learn about gravity location models. What is a gravity location model? We will look into a specific use case and solve it. Right? Finally, network optimization models. Okay, so these are the various things that you can expect as part of all these things. And we understand that there'll be supply, we understand that there'll be demand, and yeah, so on and so forth. And here I think I need to spend some more time to give you good understanding, but I'll get to this in a moment. We will also understand about transportation problems, right? Given you have three supply centers, from where raw material is supplied. Not raw material. Say you have three supply points or three plants, three manufacturing plants of a company, and you have four distributors located in different countries. Think about yesterday's plane, Boeing example. How would you distribute? How would you transport? And your goal will be to minimize the cost. How would you do that? And there will also be something called as transshipment problems. Transshipment problems means if you are supplying from source to destination, there might be a lot of intermediary, locations from where, between your supply and the centers which consume, demand centers and supply centers. Between that, there'll be a lot of intermediary, and these intermediary will not do anything. They will just act as a connecting point. Those kind of connecting points are called as transshipment centers. If there are a lot of transshipment centers, can I identify the shortest path? So we'll look into shortest path problems. Then maximal flow problems. How do I ensure that maximum quantity flows through specific, network routes? We'll understand the generalized network flow problem as part of this network, and we'll also understand minimum spanning tree problem. Okay, these are the various things that you're going to understand. And you also have certain machine learning algorithms. Okay, and we will understand about those machine learning problems as well, because machine learning is something which is very extensively used. But how do we use machine learning in the context of supply chain is something that we'll look at. Here we are going to model discrete choices. Here we will look at, what if the, output variable is categorical, and we will look into a specific use case with logistic regression. Okay, that's one very important thing that we'll look at. Then you will also understand how the coordination happens. in supply chain under uncertainty. How did I basically have worked on a few of the products. That's what I'm going to speak about. And then we'll look into yet another use case using neural networks in supply chain. How do we use that? And finally, I'll show you a specific use case of supply chain and application of forecasting technique in supply chain. And for all of these, we will make use of, I think, two tools. Number one, we'll make use of Excel, and we'll make use of something called as solver, which is an add-in. Second, we'll make use of R programming, which is pretty easy. And with respect to neural network alone, I'll make use of Python. Hey, would you teach us R programming, Python programming? No. Would I teach you an Excel? No. But I'll explain how do we solve using these. And the respective code, etc., would be shared with you. Okay, so this is what will be covered as part of your training. Now I want to spend some time answering your questions. So let me go to white box and look at certain questions. Ganga Prasad. I suppose new companies practicing theory of constraints have stopped using forecasting. They follow replenishment. So eliminating forecasting error. Oh my God. Forecasting is being futuristic, Ganga Prasad. It's very heavily used. Companies have actually started making use of forecasting in a big way. Okay, Ganga Prasad. Theory of constraints is a different concept altogether. That and this has no correlation. Towards the end, you will receive certificate, Gopal, of supply chain analytics. Pico has a question, sir, along with data science certification training, will supply chain be the good choice to add better value for job perspective? Can you explain in these combination? Yes, certainly. See, anything that you're adding to your kitty as a new certificate will carry its own sweet value. With data science, you can get a job. With data science certification training, you can certainly get a job. But if you say that, in addition to that, I've also specialized in supply chain, then certainly it will carry its own sweet value, right? It's called as economies of scope. The more you know, the more I'll pay. That's common thing, right? Training plus some specialization. For example, if you want to become a doctor, general doctor, then you have something called as MBBS. And if you want to specialize, you'll have MD. Obviously, someone with MD would be paid more. That's how this is. You can think about supply chain in that way. Will there be any Python? That's not needed, Neeladri. Our training, Python training is not needed because you'll focus on how the business problem is being solved, and we will share that code with you. But you can use that code for various applications in your workspace. But if you want to learn, then we have separate trainings for that. No, there is no placement opportunity. There is no internship that we provide for supply chain. But if someone is really interested, then we will give you some projects, but it's not within the course. It's not included. But out of your own interest, if you want to do, you can let us know. We'll see how we can help you out with that. What is the duration of the course to get hands-on experience? See, duration of the course is for 12 hours. Here we are expecting people to have some basic knowledge about machine learning and programming. If you don't have this knowledge, then I would say for knowledge purpose, you can attend. Okay. Next, Neil says we have to pay differently for this course. Yeah, absolutely. Absolutely. Okay, so supply chain analytics or financial analytics or life sciences healthcare analytics, if you want to do any specialization per se, yes, you'll have to pay extra. Any other questions, friends? So our team will get in touch with you. If any one of you all are interested, then this Saturday onwards, we will have sessions. Sessions will be on Saturdays and Sundays. Timing, etc., would be communicated by our team. Even fee, our team, when they communicate, they'll let you know, Professor. All right. So timing and fee, our team will communicate with you. Any other questions that you have? Yeah, you'll get email from the team or you'll get a call from the team. All right. All right, friends, then. Thank you so much. Will there be an extended session after this basic session? Yeah, from Saturday onwards, we are going to have, right, yoga for 12 hours. If that's your question. In India, as of now, how many companies using like Jesse component pick model? I'm not sure, team. I'm not sure about the technique as well. We will learn about that as part of the training people. All right, friends. Thank you so much. We'll connect again and understand. Thank you.